Yeah, good morning. I'm really glad to be here. This is not the usual type of talk I give. So typically I talk about the socio-technical systems that I build or study that sit somewhere between data, AI, and social computing, which basically applies to any sort of digital platform. Having said that, I do appreciate the invitation, and I do appreciate the talk as an opportunity to think about how what we have been experiencing in AI over the past 12 months is disrupting my professional life as an academic, and the community I'm part of, and the whole ecosystem, and perhaps I'm here less to give you an overview of the technical opportunities that AI provides, because I have the feeling that lots of you in the audience know already, and certainly if you were looking at the slides of the companies that are present here, they do explore some of those opportunities. I think more importantly, I'd like to reflect on some of the challenges that we have as a community, and how what we need to do to address them. But before I start, are there any academics in the room? Okay, hello. You will hopefully empathize with what I'm going to say. So my talk today was not generated with ChatGPT. It was generated by myself while sitting on a train to and back from Brussels. So this has been quite an inspiring, hopefully, use of my time. But before I start, so we hear about AI a lot, but I want to make 2 points. First, for me as an AI researcher, and I have more than 15 years of experience in the field, AI as a term is not great, mostly because it talks about intelligence, artificial intelligence as opposed to human intelligence, and we know just how hard human intelligence is to define, so let alone when you talk about the artificial kind. I and many other colleagues in the AI field think about this as capabilities of digital systems that augment what people do. So that's point number one. Point number two is AI has been around for ages. Yeah, in fact, this was one of the many graphics that neatly depict what has happened in the last 80 years. But technologies that we're talking about today, like deep learning, or transformers, have been around for quite some time. Deep learning certainly for decades, but even transformers have been around for 6-7 years now, let alone large language models. So this is a graphic from a recent survey on large language models from November this year, which basically shows that, so I think transformers were introduced in 2016-17, so this starts in 2019, with a range of large language models, so AI systems that are able to learn and make predictions from data, and are able to generalize from one particular task to another. Some are open source, some are closed source, but certainly this graphic should give you an idea of just how much is happening in this space. So AI is 80 years old as a concept. Large language models and generative AI as the sort of thing that we read about in the media these days have been around for several years as well, and it's a very hot market, and there's many different technologies that are released almost on a weekly basis, with the effect for those who want to use these capabilities, including scientists, including those who build tools for scientists, creating opportunities to use these sort of capabilities as a commodity, which definitely is positive as far as I'm concerned. So then I started thinking, well, how does AI as such affect me as an academic, but also other sciences. And probably you know more about this than myself, but AI is used as a tool to support, facilitate scientific discoveries across disciplines. So we're talking about abilities to analyze huge amounts of heterogeneous scientific data to discover patterns and trends that, at a scale that more traditional methods and science teams were not able to do. And this is just a snapshot that should make the point that these sort of methods are applied across different disciplines, from I think nuclear fusion here to medical research, certainly, but also in humanities, social sciences, and political sciences. In addition to that, and I'm sure I could learn a lot about this from this audience, AI can help us to do science better. And there's many use cases, from making scientific results more robust and reliable by increasing reproducibility and similar factors, by helping at analyzing research literature, by supporting both quantitative and qualitative research, facilitating access to scientific data sets, and more recently helping us generating code. So I'm a computer scientist. I love to see when colleagues from other disciplines use digital tools and learn to code in Python and so on and so forth. But I also acknowledge that the way we in computer science teach these capabilities to more interdisciplinary audiences has its limitations. And personally, I see AI as and its ability to create this co-pilots as a very interesting avenue to explore not just how we can close this coding divide, but also to teach us as computer scientists more about what is it that we need to teach computer science students that they can't just automatically generate from large databases of code available here. So the examples I have picked. So on the left-hand side is a project called the Open Research Knowledge Graph. So I'm a big knowledge graph fan. That's my training is in AI, sort of the symbolic kind, of the knowledge graph kind. I used to say that this was the less fashionable part of AI, and for at least 10 years this was the case. Now that we have large language models and we're aware of the limitations they have in terms of hallucinations, in terms of provenance of answers, knowledge graphs are seeing, at least from where I'm standing, a revival. So I'm quite happy about this. What else do I have here? Certainly Google dataset search. I want to mention that because, as I was saying, AI, so very powerful AI of the transformer kind, has been around way before ChatGPT was introduced. And Google dataset search, which is a general tool built by the Google team, by Natasha Noy and others to find data, including scientific data, is using some of that technology. And to some degree, some of the conversations we're having around, how trustworthy generative AI should apply, in my opinion, the same level of scrutiny should apply to some of these perhaps older but not so old advanced AI technologies that we see apply in many AI products that empower search and chatbots and others. What else I wanted to tell you here? I think this is a tool called Elicit, bottom left, which some people in my community are using. Probably there's many solutions, including here, that do very similar things, so I'd love to learn more about it. In the middle is a report that was commissioned by GitHub. So I'm going back to one of my main themes around no-code to low-code solutions for scientists. So basically, this is a report that was released a few months ago that shows that a huge majority, so this is based on interviews with almost 900,000 developers, I think, users of GitHub, so this repository where you put code. And Microsoft has introduced a code co-pilot that helps generate some of that code using AI. And this is a report that shows not just how widespread this co-piloting functionality is among different types of coders, but that it actually makes coders happy. Well, coders aren't a happy bunch, so I don't know about that. But what's actually interesting, going back to AI in science, is that it tends to help beginners, code beginners. So if anyone is interested ever in doing a sub-study on how scientists in non-computational disciplines use AI co-piloting on GitHub, that could give us some interesting data. So, right, so doing science better. Me as a knowledge graph person, I'm quite fond of data. And I do believe that data, perhaps alongside compute, is possibly the most undervalued aspect of AI today, and this is changing ever so slightly, but certainly most people are focusing on building the models, the algorithms. So using data and scientific data responsibly is something that I personally care a lot about. So with the latest large language models, foundational models, we have new opportunities to generate synthetic data. So that has implications in research, where accessing the original data has all sorts of privacy implications, for instance, because that data is sensitive, it's of a personal nature, it's commercially sensitive, and we've seen advances in the last year or so in the degree to which we can generate these synthetic data sets and continue to advance science with them. At the Open Data Institute, which is, by the way, a non-for-profit based here in London, set up by Sir Nigel Shadbolt and Sir Tim Berners-Lee, working on building trustworthy open data ecosystem. We're also looking at AI data and what that ecosystem looks like. So among other things, we're looking at privacy enhancing technologies in AI, like federated or collaborative learning. And we're also working with a range of data providers, including providers of research data. Like here on the right-hand side, I've put an example of Insight, which is a health data research hub for eye health. So the ODI helps data providers like this set up data stewardship and governance mechanisms that give not just the patients or the subjects of that data, but also researchers and policymakers and decision makers the trust that the data is shared and handled with an ethical dimension in mind, and that there is transparency and accountability on the way the data is used. Finally, I think AI has helped us also make progress in making science more accessible and inclusive. I can only recommend a course we have recently launched on FutureLearn, an open learning platform at King's that looks at generative AI and its impact on education, where education is understood very, very broadly. So this is work by my colleague Caitlin Bentley. I'm going to stop talking about how AI is transforming the coding of computer programs, because you're going to get bored of this. But maybe in terms of accessibility and inclusivity, in the introduction, you were told that I work on social computing. So part of the research I do is trying to put this technology, particularly AI, which is what I know about, in everyone's hands, and to try to understand how to build AI tools that are accessible to someone who has almost no background in technology. So a project I'm running at the moment with my colleague Effian Turma at King's is called Impetus. So this is a 3 years large European program where we work with 125 teams of citizen scientists. So citizen science is this way of doing science in a participatory way, where members of the public are engaged to collect data, to analyze data, to be involved in scientific experiments with and without AI, and we are helping them do this. So now a number of challenges. Certainly, AI is, everyone in academia will tell you that we are seeing a change in our code of conduct, in our code of practice. So we're talking about how generative AI should or should not be used in writing papers, in producing reviews, in writing rebuttals, in reviewing grant applications. And we're also seeing practices emerging from professional associations. So the example on the top left-hand side is from the Association of Computing Machinery, which is my professional association, and their policy on authorship. We're seeing at the other end, some of the technology companies at least acknowledging and promising to provide technological solutions to that allow us to identify content that is automatically generated or co-generated. It's not the easiest of tasks, but there's also other implications in terms of authorship and ownership that have to do with licensing scientific outputs, and one of the answers is responsible AI licenses, but it is an ongoing conversation about how you should handle IP, how you should handle copyright, how you should handle ownership and rights of data and scientific data, and so on and so forth. There is a challenge of misinformation that doesn't affect just science, but science misinformation has been around for a while. Say climate change as an example. And while there are studies that seem to suggest that there are risks that foundational models and large language models pose to science in this way, there's also a lot of knowledge we have from the area of misinformation and disinformation more widely that tell us that a technology solution will not be enough. So even if we're able to build augmented AI systems that will tell you where the answers come from, that will explain you how the answers were generated, that will try to ground the answers in actual curated knowledge to reduce hallucinations. You still have social effects, human and social effects, that mean that once a piece of fake news is out there, it will take 3 times more effort to debunk it, and some of the people who reached and consumed that news will never be reached or convinced. So for this reason, I work with a range of disciplines, and some of the most recent programs I've been involved in is called Media Futures. So there we're working with startups, and we're working with artists, and basically starting from the assumption that whatever problem an AI might create in terms of misinformation, whatever solution an AI technology might promise to hold, it is not enough. You need the arts, you need social sciences, you need more disciplines to create that sort of experience and to talk to people in a way that will make a difference, will create an emotion. And here on the slide I have an artwork by a very creative French artist called Gaëtan Robillard. This is the Critical Climate Machine, which is an installation that invites people to engage with climate change myths that are shared daily, unfortunately, on social media. There's challenges in digital commons. So you may have heard that sites like Stack Overflow and others, which have been used extensively to train the latest generation of AI models, but also who have been providing a useful source of curated specialist information through contributions of volunteers, are seeing a decrease in traffic. Because people now are using generative AI, at least for some subjects. And I think this trend is going to worsen in time because, at least from my research in social computing, I know that one of the reasons why people contribute to Stack Overflow, to Wikipedia, to all of these digital commons goods that we are taking for granted, is because they like to see their work acknowledged, and that doesn't happen anymore when the answer is automatically generated from millions, if not billions, of data points. We're also seeing a shift in what open source is, or what some of the big tech companies like Meta are trying to shift the conversation about what open and what digital commons should mean, which I'm sure will develop in interesting ways over the next years. There is a challenge around data. So I said earlier that data is something that I care a lot. There is an understanding now with the latest developments in AI that, first of all, they're very costly to build and to run, right? So the bar chart here, you don't need to see exactly all the data, but it basically just shows that it is impossible for most organizations, let alone scientific groups, to train their own models from scratch. And unless you have tens, if not hundreds, of millions of dollars, you will not be able to do that, putting aside the environmental implications. So in that sort of space, even big technology providers are holding back from releasing new generations of the models they already have because of the costs of running the technologies. So there's many ways to deal with this. There is a trend in machine learning called small language models, which is trying to see how you can build fine-tuned architectures, machine learning architectures that work for specialized tasks, perhaps, but with way less data. There's also a greater understanding that the AI community as a whole, and that AI engineers and practitioners need to pay more attention to data. Not only when data is scarce or when you need to label it with specialist knowledge, but also because, especially now with ongoing AI regulation, every application of AI technology, especially in a high-risk domain, will have certain compliance requirements in terms of the data that was used to train the model, and in terms of the sort of harms and risks that that system could pose. So data-centric AI is becoming a thing, and not just as a sub-community within machine learning to support AI engineers in documenting what they do with data. And well, actually, to start with, the shift is really in realizing that when you build an AI system, data is not just this static object that you download from a dataset repositories like Hugging Face and then start training your model, but data is a living artifact that will evolve and that you need to pay attention to. And that starts with analyzing that data to make sure that it is fit for purpose, to augment it, to make more out of it, but also to perhaps balance it and make it more representative. And this is not something that, I mean, my PhD students, including, that the machine learning community is used to work on. the machine learning community is used to work with benchmark data sets, which have their role. I mean, they allow people to compare their solutions against the same baselines. But looking at solving an actual problem in the real world, people quickly realize the data that they've been trained, the models, whether in a science scenario or somewhere else, is by no means a reflection or similar to the benchmark data that they have accessible. So then they start building data sets. And like in statistics, like in data science before AI, when you start building a data set, it takes 80% of the time in the project. Especially now, as we have lots of AI models that are available via APIs and in general as a commodity. So when you start thinking about how machine learning practitioners or other users of AI will build their solutions, you then need to start thinking about questions around how people will interact with these data sets. What sort of solutions are they going to be using if they still have to label some of the data? If they do, sometimes scientists use digital platforms called crowdsourcing platforms, where they recruit from all over the world to label data points. That has all sorts of ethical implications, because it is a hugely unregulated market, and lots of the people who participate on those platforms, so-called crowd workers, come from the global south and that part of the world. There's also, I mean, the way AI tools and platforms are built today don't make it that easy for machine learning engineers to work with data. So one effort I'm involved in is called Croissant. We didn't think about the branding too much, but it is a standardization effort that is open to anyone who's interested in working on this. That is hosted by a non-for-profit called ML Commons, that historically has been around to standardize machine learning benchmarking, so evaluations of machine learning models for different tasks. So this working group that I'm co-chairing is looking at creating a metadata standard for machine learning datasets in different fields that will solve three problems. On the one hand, interoperability across different machine learning tools and platforms. So you may know that if you prepare your data to use in an AI tool like PyTorch or TensorFlow, that data will have to be structured and formatted in a slightly different way. Yeah, so that adds overhead to how machine learning engineers work. So we're creating a metadata standard that extracts, that describes in a machine-readable way how the data is organized, so that we make that loading of the data and the processing of the data across platforms easier. That format is also supported by Google Dataset Search, which means that we can now improve dataset discovery across the individual repositories that people might know from their experience. And lastly, by having this machine-readable metadata standard, we hope to improve data documentation practices. We're building on top of approaches like data sheets for data sets and data cards that have done a lot of empirical research to come up with a list of categories and dimensions that someone using a machine learning data set might be interested in order to be able to realize whether that data is relevant for them, what the limitations are, what was the original purpose, and to potentially augment or process that data further to make it more likely that it is suitable for the model at hand. So if you're interested in Croissant, by all means get in touch after this as well. So we're going to launch the standard, the first version, in 9 days, so this is quite exciting. And it is an open extensible standard, so we already have planned extensions for geospatial datasets, for health datasets, for multimedia, so audio datasets as well. So if you have other use cases, I'd love to talk to you about that. I'm almost done. Human-AI interaction. Say, we're using AI a lot as a tool to augment what we as scientists do, like carry out reviews or summarize our related work to understand what others have been doing in the field. All these tools need to build on top of the practices and processes and tools we already have. And that requires a lot of user-centric research, just to understand how do people rely on automation, on AI automation as a new type of automation? How do people write with AI? How do they, what sort of explanations they need about what the AI has been doing? What sort of agency they need? What happens if the AI co-pilot writer has made a mistake? It turns out, among other things, that people tend to look at ChatGPT and similar technologies as a companion, as a human companion. So that means that when that tool makes a mistake, people don't look, and when they are editing that content, they assume the mistakes will be the same or the reasons will be the same as if they would be working alongside a fellow human. So this is just one of the many questions that human-AI interaction has to answer, and I'm sure there's going to be a very rich field of research, and science and scientific tasks could be a very could deliver a very interesting set of use cases there. And with that, thank you very much for inviting me, and I hope I've told you at least a few interesting things, or at least gave you at least a few pointers to think about, and I'm looking forward to the questions.